This time we try to solve Sudokus like a human, instead of just trial and error and backtracking. So let's start with a Sudoku grid and fill out some numbers. Let's take the first cell as an example. Can we fill the numbers from 1 to 9 in there? First we can eliminate 5, 4, 6 and 9 as the row values, then 9 and 7 as the column values, and 2 and 3 as the block values. Then we can do the whole process for the whole first block and then for the whole Sudoku. The next step is to just fix the numbers that we can already fix, like the 1 in this example, and then remove again as before, then fix again, remove again, fix again, and remove again until we can't fix anything anymore. So let's just focus on one row. Here we take the third row and just zoom in a little bit. And then we create another row which just has the values from 1 to 9 filled in and create a little graph structure. So for the first cell in our third row we have the values 1, 5, 6 and 8 possible. So we connect to the cells 1, 5, 6 and 8 in our new row. And do the same thing for the other 8 cells. And for the third, fourth and ninth cell we just connect to the one number that is already given. The next step is to find a maximum matching of this bipartite graph. So basically we want to pick some of the edges such that every cell has a connected edge. So every cell on the top as well as every cell on the bottom. So every cell has a number and every number is used exactly once. So in this case we just pick 1 from the first cell, 6 from the second cell, 3 and 9 are already given. Then we pick the 2, the 7 and so on. The general idea would now be that we find all possible matchings and hope that some of the edges are never part of a possible matching. Unfortunately, finding all matchings is just too slow, so we need to use a lemma for that. And here the Birch lemma says an edge belongs to some, but not all maximum matchings, if and only if, given a maximum matching, it belongs to either an even alternating path starting at a free vertex or an even alternating cycle. So we already have a maximum matching here in blue, so maybe we can find an even alternating path starting at a free vertex, but that can't be the case here because we don't have a free vertex. A free vertex would basically happen if the 0 could also be possible, and we only have like 9 cells in a normal Sudoku, but can fill the numbers from 0 to 9. Then the 0 could be a free vertex, and we would also have to consider that. That is important for some other problems, but not for the Sudoku, so we can just ignore that for now. So let's consider even alternating cycles. So even just means that we have 2, 4, 6, 8 and so on edges, and alternating here means that we have to use one blue, then one white, then one blue, then one white edge, and so on. So let's find some even alternating cycles then, which we will mark in green here. So the first one, we just start from the second cell and then go to the number 6, then to the 7th cell, go to number 5, to the 8th cell, go to number 8, and back to the second cell, which closes the cycle. And we continue to just find some more cycles, and until we can't find any cycle anymore. And then we combine all the green edges that we found before and see that we haven't used 2 edges. Now, based on the Birch's lemma, these 2 edges can't belong to any possible matching, and we know that we need a possible matching as a solution for our Sudoku. So basically, when these 2 edges can't be part of a solution, which means that when we have a look at the first edge from 2 to 7, we know that the 7 can't be the number in cell 2, and in the 7th cell it can't be the number 2. And there's also like a logical reason for us humans for that, because in the 5th and the 6th cell we have to use 2 and 7, so we can't use 2 and 7 in any other cell. Now, in the original Sudoku, we would do this for every row, cell, and block at the beginning, and whenever we change something, we would also update relevant cells as well. But we can maybe show that in another video. So thanks everybody for watching, and if you want to read more about solving Sudokus or other puzzles and some other constraint types, please check out my blog opensource.as. It's also in the description down below, where I have currently way over 20 blog posts about writing a constraint solver in Julia. And special thanks also to my Patreon subscribers, also linked down below, who support every project that I do, and I very much appreciate that.